Okay, so we're here today to talk about structured team-based solving techniques. So we want to get people to have a think about how, as a team, we can look at problems to solve that are a bit more meaty than some of the things that we see as we're doing just waste walks and process maps, etc. So what are those things that require a bit more thought and a bit more effort to solve, rather than some of those immediate things that we see as we pick up and look at the work in detail? Certainly what we would suggest through some of these techniques is about, still for those things that have an obvious solution that we can try, is that we get on with trying those things. So we're going to talk about problem solving techniques today. So the first thing we'll do is we'll have a quick review of the last session and the call to action. We'll have a chat about the importance of team-based problem solving. We'll then talk about this problem solving cycle. There's lots of different methods for problem solving. If you look at lean and problem solving, you'll find there'll be different methods. We're going to use something called DMAIC. It's a fairly popular one, but it's fair to say they all follow this same structure of defining the problem, how do we measure that problem, understanding what's the root cause, selecting a solution, and then thinking about how you control and embed that solution. So we'll go through those steps. So we'll talk about how you define and measure a problem. We'll talk about the tools and techniques for measuring problems and identifying root causes. We'll do a quick exercise on 5 whys. We'll then talk about how you do selection of the solutions. And then finally, as we get to the end of the session, we'll do a quick summary. We'll do a final exercise about going through all of those steps on a problem of your own. And then we'll do the call to action and we'll introduce the next session. So we're halfway through the modules. We're in module 3 about improving productivity in critical operations. Last time we talked about activity sampling and how you can use that to look at the detail of how people operate and do tasks. Today we're going to go through practical problem solving, and next week we'll talk about short-term interval controls. So a quick summary of the previous session when we talked about activity sampling. So activity sampling is there to give us those further opportunities to reduce non-value add or variances between individuals. So we spoke about this in the context of, if we can study how things are done in especially those high volume, those high labor areas, we can see how small differences can actually make a huge improvement. So where we see things like picking, with lots of people doing those activities, we can look in more detail about how those tasks are undertaken to understand, are there differences in the way people work? And actually, could we make some small improvements which multiplied up across a whole team would make a large improvement? So what we do with activity sampling is that we look at the frequencies of activities within a work system, and we take samples rather than observing everything that happens. So we take 10-second snapshots. So we look at someone and we see what they're doing every 10 seconds. And that gives us a view of, over a period of time, what's the split of the work. So I think I described a process for doing this in terms of plan and set up the activity. So make sure that you have everything in place to do it. Make sure the people you're observing have been had a discussion with to ensure that they're aware of why you're doing it. Complete the activity sample, analyze the sample, and then on the basis of that, do some action planning. Now, I chose DMAIC. There's lots and lots of different things that's techniques for problem solving. And if you look on the web and look for problem solving with lean, you'll come up with a number of techniques. I've chosen DMAIC because it's probably the one that most people use. They all follow the same structure. So I'm using this one on the basis it's the most common. So first of all, it goes through these 5, it's 5, isn't it? Yeah, 5 stages of define, measure, analyze, improve, control. So starting with define. So define is about being really, really clear about the problem you're trying to solve. So having clarity about what is the problem you're trying to solve. Measure is about measuring it. Analyzing is about, once you understand the scale of what the problem is about understanding the causes of that problem. Improve is then about saying, well, can we try things, test things, make some improvements to ensure that we resolve the root causes. So this is about selecting solutions. And then finally, control is about ensuring that's embedded across the whole of the organization. So that's where we were just discussing making sure that you get consistency for everyone. So then we start going round again. So we start to do more improvements. So within define, it's also useful to think about your problems and also think about where you want to get to. So if you've got an issue where you've got an issue with 20% quality or something, you might say, I want to improve by 10%. So that's about defining the problem. So all of these, this is a technique at an overview level, is really useful when thinking about problems. But it's also fair to say when you find some problems with some obvious solutions, getting to the point of trying things and making improvements is really important as well. So I really advocate thinking about this as a general structure, but also I advocate if there's some obvious answers to some things and you can try them in a fairly low risk way, why would you not just get on with them? So with the types of work you've done so far, I think, you know, very much follow some of this thinking in terms of ensuring that you do those things that are really simple. Don't sort of get bogged down in making sure you've gone through these more detailed processes. So that's the overview of problems. So I'm going to talk a bit more about how these things work. So first of all, defining the problem. In the first instance, I'd very much suggest you try and articulate what the problem is. So what we often find when we work with businesses who have some large problems is they're not really clear about what the problem is. So we get lots of people jumping to solutions. I think as human beings, we have a natural bias towards thinking about solutions rather than being clear about what is the problem we're trying to fix. So we want to try and articulate what the problem is, where it's happening, when it's happening, and what extent is the problem and the consequences and the impact. So I've made up a problem statement at the bottom there as an example. So there's an increasing level of underfilled punnets coming from the field during the previous season, resulting in additional work or waste in the pack house. So that's a generic problem statement that's just saying, we've got a problem and we're just trying to describe what that problem is. So that is what we're doing within problem statements. The next step within that problem statement definition is to make sure we measure the extent of the problem. So this is about define and measure. So when we're looking at this statement, I would be looking at, can I quantify how much or how many punnets that we have overfilled or underfilled? The previous season, would I be able to define the time period of that? And could I define the additional work and waste in the pack house? Could I measure all of those things? I'll show you some techniques about how you do this in a second. So a better quantified measure problem statement would be, there's been an increase from 5 to 10% over underfilled punnets coming from the field during 2019 season, resulting in additional work equivalent of 1/3 of an FTE and additional waste of 3% in the pack house. So very, very clear about the scale of the problem. Again, I would just go back to sometimes these things are fairly obvious and doing the measurement might be a bit too much. So once you've got this as a problem statement and you've defined the scale of the problem, you can think about where you want to get to. So if we took this problem statement, you might want to think about, do I get to a point where I've got back to 5%? Would that feel like a reasonable level of over and underfilled? Would I want to get it to 3%, 8%, et cetera, et cetera? So you define an outcome statement that says, you know, we will know we've succeeded once the over underfilled punnets are at 3% in the season of 2021. Would be a good outcome statement associated with this. But it's good enough in lots of cases to have this at a level of, do I understand what the problem is? Can I get consensus from the people I work with to say what the problem is? So we've used some of these already. So quantifying problems, as you've probably seen, Neil and I are fans of being able to do things quick and easy, not spending too much time doing lots of over analysis. So some of the tools you've already used in terms of things like waste walks, activity sampling, help you quantify the scale of a problem. So it might help you in this instance in terms of, let's take, for example, the activity sample. would give you some idea of the additional work that's happening as a result of people having to rework the overfilling or underfilling of punnets. The other ones that we find are particularly useful are things like tally charts, measles charts. Sorry, I'm expecting you to remember these. I'll go through each of these in turn. Something called Pareto, Fishbone diagrams, and 5 whys. So the first 3 are particularly useful in measuring what's currently happening. So let me take you through each of them at turn. So tally charts are a simple way of, if we know there's a problem, we get people at the point where the problem is occurring to capture how often it happens. So I'll give you an example, because we did this in a pack house. So we found in a pack house, teams were meant to be weighing, I'm trying to remember, it was fruits. Can't remember if it was raspberries or strawberries. Can't remember. Anyway, they were weighing them into a punnet, and then the machine was wrapping and labeling them, and then there was a quality check at the end. Now, when we watched the line, there was a person at the end of the line who was picking them up and taking them off because they thought the quality of the product in the actual punnets wasn't right, something had gone wrong with something else, etc., etc. So we had a process where the purpose of it was to make sure we'd got the right quality fruit in at the start of the process to a certain weight, and at the end of the process there was someone checking them and then taking them off the line. So we got that person on the end of the line to start to fill in this tally sheet, because it was simple. They just have a piece of paper on their workstation that they just go, every time they remove one because there's a problem, what is the problem? And we get them to capture it through tally sheets. So it's a similar technique to used in terms of the activity sample, but it's a very simple thing. So I do think I've got a template for a tally sheet. So we will send these over after the session. It's very simple, about just creating something that is simple for someone to use at the point where you want them to capture data. So that's a tally sheet. A measles chart is similar, but what you're doing is you're looking to capture where errors occur. So I've got a couple of things on here, because this starts to show you where problems are. This works particularly well on forms and things like that, where people say, I never get this information, or whenever I get the order, or whenever I get the instruction from my manager, I don't have all the information. So again, what you get them to do is have a blank form and just start to capture where the problems are each time they occur. Or in the example of the label there, if we're constantly getting issues with labels or errors with labels, again, you can get the operator just to mark every time they occur where they're occurring. And you'll probably not be surprised that you'll start to see some patterns in terms of where the errors are and where the issues are being caused. So again, it can be applied. So a similar thing to the tally charts, but particular to an area, or you might take a particular product. So we've certainly used it within our manufacturing and engineering days, where we would have failures of a particular product, and we would use measles charts to identify where those failures occur. Okay, so Pareto. So I always struggle to explain Pareto, but it's the 80-20 rule. So whenever you capture data about performance, you normally find that most of the problems come from a few things. So this originally was born from the fact of, 80% of the wealth of the world is in 20% of the people, but that's not true. It's a lot more stark than that. But when we look at all of the different reasons a problem occurs, we often find that 80% of the occurrences of that problem come from 20% of the different reasons the problem occurs, so the cause of each of those. So going back to that, the line fill of, people, the lady at the end of the line taking things off the line to put elsewhere, once we'd done that analysis, we found there was 1 or 2 things that contributed the majority of the failures, far more than others. And the reason to do this bit of analysis is, obviously, if you can fix those 1 or 2 things, then you can resolve 80% of the problem. If you don't do this analysis, the danger is we spend our time, because we can see solutions and we're a bit solution orientated, we can spend our time down the other end of this graph looking at what are those odd things that we can see some solution to but have only happened once or twice. So it's really good to think about when you start to get this information and get some measures of how things are actually performing and what problems are occurring, that actually you put it into this format, think about which are the highest common occurring things and look for the Pareto. I think I've tried my best to explain that, but if anyone's got any questions afterwards, they can ask me. And as ever, if people wanted to have a go at doing this, I can help them. Again, I have a template for you to use, which you can just put the data in it and it will create this Pareto graph here. So it will do it for you. So in this case, this is a lot of data points. Just as an example, there's there's 35 different data points, and of those 35 different data points, the 80-20 is those top ones. So those would be the ones you look at. So if you put your data points in here and the values, it will work out this Pareto for you. Okay, so we'll move on to things called fishbone diagrams. Sometimes we're now thinking about how do we get to the root cause of a problem. So there's lots and lots of things around Lean this, but we have to think about when a problem presents itself, we want to get to the root cause of it. We want to get to the real underlying issue that's occurring, not just try and fix the thing as we see it. So the fishbone diagram is just about collecting those different things and putting them under different groupings. So this is a classic way of doing it in terms of methods, machinery, management, materials, manpower, that there might be a number of things that could be the potential causes that result in the effect we're seeing through our measurements of the problem. So always looking for root causes. There's a far simpler way of doing this, which I'll come to next. So just constantly look for root causes. Simpler way of doing it is to ask why 5 times. So someone presents you a problem. The general thinking is that if you ask why 5 times, you will get to the root cause. So it's a case of having that in your mind. I wouldn't suggest you, if someone comes to a problem, just asking them why 5 times without some sort of conversation is particularly helpful, because you might sound a bit like a petulant child. But thinking that asking why 5 times gets you to the right root cause of your problem. So just to get to root cause, why 5 times, and you should start to get into a conversation about the root cause. Just have a think about a problem. Take a simple problem, yet don't try and solve world hunger in 5 whys in this exercise. Just take a bit of time to think of a simple problem. It can be a work-based one, or it can be something else. And just either between you ask the question or ask of yourself why, and keep asking yourself why, and see if it helps you drill down a bit to root cause. So if I sort of give you 5-10 minutes to do that, so you're just going to think of a simple problem, and either between you will ask each other why, or individually just ask, go through that process of asking why 5 times. I think you've seen this before in terms of selecting solutions. So once you've come to these root causes, it's then about thinking, well, what do we do about it? How do we actually now select a solution? So we use this matrix that helps us think about impact and ease. So I think you covered this in an earlier session with Neil, so I won't delve into this too much, but about selecting solutions. Also within selecting solutions, and again, I know Neil will have talked about this, one of the most important things, and I think we do labour this quite a lot, about testing things, trialing them, just give it a go. I think if the risk is low and it's easy to try, why not try it? So within Improve, we would still, even with the amount of analysis to get to this point, we would still encourage you just to give things a go, to try things out, to test them, because by doing that, you get a far better understanding if they work or not. So always do that in the first instance. So and then we come to implementing solutions. So this is about ensuring that improvement has been realized. So making sure that what we've put in place is actually delivered thing that we set out to do. So if you remember when we talked about define, when we got that measurement of what the scale of the problem is, I encourage you to think about what would good look like. So have we actually realized that? And also to make sure that improvements sustained through standardization. So I think this is one of those ongoing things that we'll talk a bit more about how do you ensure, therefore, that if there is this one best way, and I think Alex and I were describing this about this one best way, how do we ensure that everyone's doing that through, things like work instructions, through training, through videos, etc., etc. And there's another point that says, well, could you do more and go through the cycle again? So selecting solutions, just ensuring that we use this matrix of impact and ease. So have we picked the things that are likely to deliver the benefit and actually are the things that are easy to do? So how easy are they to implement? So always looking for those quick, easy, high impact solutions. Finally, into implementing this solution. So yeah, ensuring that that improvement has been realized, sustaining the improvements through standardization, and then thinking about, could we do more? So considering we've got the benefit we set out to do, is there an element of we could go back around this cycle that's sitting up at the top left hand corner of these slides? So there's the cycle of problem solving. So I thought what we'd spend a bit of time towards the end of our session, and I might just give you 15 to 20 minutes to have a go at this, is to really do a quick problem solving exercise. And the reason to do this is I think there's an element of using this method in every problem that presents itself to you. Doesn't mean you have to go to some of the extent that I've spoken about, but also it's a very useful thing as a team who are trying to improve things, or a management team, just to go through the thinking of, have we really understood the problem? Do we know what the facts are about that problem? Do we now understand what the root cause is once we've understood the facts about the problem? What things could we do and what would be the priority? And how would we make sure it succeeded? So how would we make sure it was embedded in the organization? So what I'd like each of you to do, and I know again I'd suggest this in businesses, is think about a problem and go through this logic. And it's something that you can do as a quick problem solving exercise with anything. So I'd suggest you have a think about a problem that maybe is a business problem you have. If it's one of the things you've already done the 5 whys on, that's not the end of the world. You could do that as well. But all I want you to do is go through the logic of saying, defining what the problem is, what do you know about it in terms of facts, analyzing where the problem is occurring, and what do you think is the root cause of it, improving, what would you do about it, and then what we do to control it to ensure that it succeeds. So this is a DMAIC. It's useful. One thing I didn't discuss, which I ought to just say, it's useful if for some of these bigger problems, it's really useful to get teams together to discuss. So it's a great mechanism to help team-based problem solving, which I think I said at the start, but didn't explore it enough. Where actually, if you've got people involved in the process, get them involved in doing this as well, in terms of going through, defining the problem, measuring, analyzing. Because as we've discussed a few times, those people that do the work are going to be far better in terms of understanding what's actually happening to help you fill some of this in. So just go through it once more. It's about defining the problem, measuring the extent to which the problem is occurring, analyzing the root cause, improve by selecting the appropriate solutions, and then put in place the controls to ensure that improvement is realized and sustained. So we've got a couple of weeks until I see you again, and we'll be talking about short-term interval controls next time. So if you've got, obviously carry on with your projects in their current state. If you want to have a go at using the DMAIC and the problem solving techniques, then please have a go, see if you can, find some problems and see if you can go through the logic of it and think about how you use it in real life and in real practice. So it'd be good to hear from people if they've had a go at using it. We'll send around the slides and the templates, etc. Just try as you go through. The two takeaways for me is, if people present a problem to you, if you're having a conversation, try and go through that 5 whys, try and get to that root cause. The second takeaway is if people present you a problem and you've got a bit of time to discuss it with them, just go through the logic of what that DMAIC says in terms of defining the problem, measuring it, thinking about what the root cause is, looking for solutions, and then putting something in control.